We said in last session that what we mean by the belief in part transfer is that the mental space does not correspond to the physical space. And we saw by the drawing on the blackboard that when we have like two systems that are far away from each other, they do not look like each other in the physical space on the surface. They might be close in the psychological space in a sense that the two skills that are required to handle them, to manipulate them, to operate them, they might be pretty much relevant or very close or similar in the psychological space. So it comes from this notion that it makes it possible for human skills to be developed by practicing abstract tasks. Now, you should just learn this definition of abstract task and what it means. And can any of you tell me what I mean by abstract task? Why abstract? And if you think about it in the context of part transfer, what do we mean by abstract task? Yes. A task that can be applied to multiple skills. Yes. Or in other words, a task that is abstracted away from specific cases or specific real world examples or tasks and is not a real world task, but is itself a task. It does not have the details of a real world task, but it is still a task. And any other thought on what this might mean? So when we talk about abstract tasks, they are basically the tasks that do not exist in the world. Or they are tasks, but the tasks that humans artificially came up with. And they usually use certain symbols or rules in a hypothetical way. So you have symbols, rules of those symbols, and hypotheses. And it's just man-made, it's made up. It's not in the world, it's not some working with a system. It's not a real task, but it is abstract. So when we talk about abstract tasks, it's basically this nature of unreal, some hypothetical, symbol-based kind of tasks. Yes. Yes, sure. We'll give an example of what we mean exactly by that. If you remember the previous session, we had like that network of components and connections. That's, for example, an example of an abstract task for troubleshooting, to find the faulty component. It doesn't exist. That is not troubleshooting in the world. That's not in any electrical or mechanical system, but it is abstracted away from the kind of things that we see in the world. And again, it's in the hypothetical space. It has certain rules, and it is used for that kind of low fidelity training. So that's one example, but we'll review more examples, especially in the next week. So here, one example is high school math, for example. So think about trigonometry or similar topics in high school math. Why is it abstract? Why is it in that hypothetical? Yes.
I would say it's because it's not being applied to anything. You're just going through the motions of being able to solve it. You're not applying it.
Yes, you are not necessarily applying it to any real problem. It's just a practice. It is abstract. It's basically useless at the moment. but it can be applied, but at the moment, the purpose of its education is not to apply it to any specific real world problem. So the reason that it's abstract is because there is no guarantee that those specific things that we learn in high school math will be applied in our future job or life. We may never use it in our entire lifetime. But we all practice them in high school. So if you think about the belief in far transfer, this is the same thing. So the reason that we learn high school math is basically to increase the capabilities of human mind. At least one of the main reasons is that. And the goal or the hope or the assumption is that that kind of practice, that kind of training, which high school math is one example, can kind of train the brain that can be applied to a range of real world tasks in future. That's an assumption. So again, the reason that we are discussing these issues is because we want to just give you specific examples of what we mean by far transfer, or how it is related to basically a lot of important things like the system of education that we have and those sorts of things. So do you have any question about this, by whatever we talked about now? So another example is history. So you might say these are facts that we learn, they kind of are on the opposite side of training and practice. But again, there is no guarantee that we even remember things that we learned in high school, like about ancient empires or those sorts of things. We may forget them after 1 or 2 years. So why do we learn them then? What's the point? Again, it's because it is assumed that that kind of practicing with knowledge, committing things to memory, can kind of train the brain. Of course, the hope for those who design those courses is for you to remember them by practicing them over and over, listening to news, following things, so that you remember the capital of countries, their past. But it doesn't happen necessarily, and it doesn't happen often. And you ask people after a couple of years from high school, they don't remember things that they learned in high school. So the goal is that this learning process is trained, and so that people in future can have an easier time learning new knowledge. That's one, or the primary assumption of the system of education. Again, another example. These standardized tests like SAT, like GRE. So we take these tests as entrance tests or tests that can help us to enter universities, graduate school. And usually these tests have different sections like verbal section, quantitative section. And again, the specific content on which we are being tested on does not matter, because those are specific mathematical formulas or those specific meaning of certain words, we may never use them in our lifetime, but it is still being asked and tested on these tests. I mean, I just said you the answer to this question. So that's the reason that it is abstract. It's basically this idea that if you know how to do these types of tasks, you have an easier time learning similar types of tasks or other types of tasks, quantitative or verbal section of those tests. So these examples like standardized tests, like general education, like learning about facts in history and geography, high school math, these are all examples that abstract and symbolic learning of these materials can basically benefit us, both in academic activities and in practical affairs or in our future jobs. And there are a lot of research that show that these things like standardized tests or testing in general is beneficial for human learning because it engages human memory, recall of information, and it's kind of the same notion that the human brain is a plastic system that can be trained and gets better the more you work with it. So you can think of other examples like high school writing assignments or even sports. You may just practice certain sports. You may never just repeat them in future or use them or follow them ever. So this basic belief in general education is rooted in this belief in far transfer. Or basically, if you think about far transfer, it's another representation of it is in the form of general education. So on the surface, they may seem unrelated, but if you think about it more, you see that there are a lot of similarities in their assumptions. So this belief, this setting of our educational system, or this kind of structuring our educational system, primary education, K-12 education particularly, is associated with figures like John Dewey, educational scientists or psychologists, who came up with this idea that it is intrinsically beneficial for people or for students, young people, to practice on these topics, to learn general knowledge about the world, to learn to some extent or to some level general mathematics and things like that. And that's why we have this current system of education. But there are a lot of criticisms, and a lot of people, a lot of researchers would say that there is no evidence that this is the most efficient system that we can have. But why not having real problems, starting with real problems, even for children, for young people, and presenting them with real problems and just going back and saying that you see these specific cases of real problems. Now there is, for example, the mathematics behind it to design it, or to show them the reason that we have mathematics in engineering, instead of teaching them math with almost no reason and telling them that, well, in future you might use it. You might use trigonometry. I can't pronounce it now, sorry. But or similar things, or integrating, or derivatives, or things like that. So basically in that time, in that moment, the child says, well, okay, we should just learn it because we have to learn it. But you can have a different system of education starting from specific real world cases or examples, and then going back and showing them that that's why we have these things in math or similar topics. So although it's pretty much established for hundreds of years, it may not be the best system. Again, it may not be the best system. It may be, it may not be. And again, there are a lot of criticisms on it. Different countries probably have different systems, more or less. And the question is, can you think of any other system that exists and you're aware of that is not like this, that is different from this? Yes.
And I think that in trade school and like learning how to become a firefighter are one of the education that don't really allow.
Yes, exactly. So in many countries, including the US, there are things like vocational schools that after like brief education or with high school diploma, you go to vocational schools after 2 years of spending time on specific tasks, mostly technical tasks. You just learn them, you practice them, and then you go to the job market specifically for those tasks, instead of going through university mathematics, engineering mathematics, learning about a lot of, again, abstract stuff. So yes, vocational schools, like these cases that you see, they teach specific topics instead of general abstract topics. So they are basically designed to provide this opportunity for people who are not interested or who do not believe in that aspect of far transfer, or do not believe in general education to some extent. They can just go and learn specific skills. And so we said John Dewey was behind, one of the main figures behind that. And you remember we talked about the belief in near transfer before this discussion on far transfer. Can you guess who was the person, the main figure, who supported specific education or vocational education? Yes?
I remember his name.
Yes, do you remember the name? Yeah. So it was Edward Thorndike. And the person who was behind the belief in near transfer and who established the idea of identical elements theory was the person that in that time was the main figure, again, who opposed this idea of general education and tried to establish and popularize specific education that can readily be used in the world. So his ideas completely are compatible, because when you believe in identical elements theory, when you believe that only near transfer exists, you should only practice on tasks that are transferred to very similar tasks. Then abstract materials, low fidelity materials, are not that much use in the world. So do you have any question about this idea of general education and its relevance to part transfer? Yes.
Things like standardized testing, it's represented as being part of general education. Though I will make an argument that it's kind of completely separate from general education itself. It's just a ranking system that was developed after the fact to try and rank students and try and set some standards for getting people through being put in place. Do you think it genuinely is enough for being part of general education?
So I personally did not categorize it as part of the general education, but in our context of conversation, you can see that, for example, the content of the test, say GRE or SAT, comes from the topics that are taught in high school or in university. So it's basically either verbal skills, which are again academic kinds of tasks, knowing about certain words, or knowing basic mathematics, high school mathematics, or more advanced mathematics. So it's basically very much ingrained and comes from the system of education that we have in K-12 education or postgraduate or post-bachelor education. So, or secondary education, sorry. So it's basically that its material comes from the same, but regarding our focus here is on the fact that the kind of things that we are being tested on is abstract, is not specific. So the question, for example, you go to a job interview and the person who asks you a question those questions are usually the types of questions that you will definitely encounter in the job. So it's programming, just write a program that does this or that. Or certain specific jobs like mechanical engineering, how do you design the system, for example? And it's very task specific. But in those standardized tests, it's not the case. It's basically some abstract questions that you may or may not use in the future of that major or for your future life. So as you can see, it is still the belief in this kind of abstract testing on abstract materials and the belief that that might be used for future. That's the kind of perspective that we're more focused on. But you're right, it might be categorized not as like kind of main system of education, but it's testing, which is categorized different. Any other question? So another example of the same belief in part transfer is tests, but not the standardized test, but test of general intelligence. Intelligence test. So the belief behind the intelligence test is that we can test people's real world performance in certain specific tasks in engineering, in anything out there, programming, managing, teaching. So these, if you consider them as real world tasks or jobs, the belief of general intelligence is that we can predict people's performance on these real world tasks by testing them on abstract materials. Again, those abstract materials are not used directly in those tests, but it's used just to test general intelligence of people. And the belief is that those that score higher on those tests are more likely to do better in those real world tests or in their job. So the main person behind this whole test of general intelligence was Charles Spearman, English scientist. And what he found was that he collected data from students, like high school students, for example, and he found a correlation in a student's performance in different topics. So he argued that if a student, for example, is good in history, it is more likely for that student to be good in math for different topics. He observed this correlation. And it later became known this as the G factor. So there is one G factor, he argued that there is one underlying factor or one underlying cause, whether physical or hypothetical. And this G factor or general intelligence factor is causing the students to do better or worse in school. If that G factor is better or higher, that student is better at everything. If that's lower, that student is not doing good in those topics. And it became known as intelligence or G factor or general intelligence factor. So based on what your experience is on just dealing with your classmates or knowing your high school years, do you think that students' performance in different topics are correlated? Do you think that if a student is better in, say, writing or composition, it is more likely for that student to be better in math? Yes?
Michael, and also it feels like it depends on the way they approach it. So if you have certain study habits that you across the board for each subject, I think that could potentially correlate, but I don't think it all do.
Okay. So yes, good response. And one thing is that it might be due to the study habits or the kind of activity that that student has or does or is practiced on that might help him or her to study different topics better than other students. And it may not be because it is the math or intelligence in mathematics that is correlated with the intelligence in writing or composition. Any other thought? Yes.
Thank you so much. And I think that really depends on the similarity of topics that you sometimes like composition and math. They don't have any similarity to work on the tasks or really kind of work. So I feel that that would not be that correlated with the math and physics. And know that they're going to utilize numbers. So there's some sort of similarity. The content is not the same, but there's
Yeah, so you're basically endorsing this identical elements theory, that if there are identical elements between these different topics, they might be more correlated than if there aren't as many identical elements. Like, things like math and physics, they have a lot of shared requirements. You have to be good at least to some extent, good at math to be able to solve physics problems, for example. Yes. So you mean it depends on, like, individuals are different in their approach. And so do you think that this correlation exists, like based on what you remember or based on what you can think of? Do you think that people are better at everything or nothing? Or it's just like some people are good at certain things, but not others?
I think it's because of carrying everything from the process, it's like their own mind. But some people are just better at definition.
Okay. So depends on the individual difference here. And some people might be better at certain things or might have certain methods that might help them in certain topics. Any other thought? Yes.
And Nathaniel, and I would say that definitely is some sort of correlation. Typically, like the students taking like AP math or something, you won't really see them doing. They might take like regular English still, but they won't be like failing it typically. Like they'll be around like the same area doing good, but they may not like be doing the best in all subjects, but they wouldn't be like doing the worst in others.
Okay. So there are some level of correlation, but it's not like 100% correlation. Okay. And I think that was what Spearman found in the time. That if you just search Spearman findings, he has this table of correlations between different topics, and it's like 0.7, 0.8, depending on the topic. But yeah, so go ahead.
To pretty much build off of that, I don't really know if this more or less supports the identical elements theory, but what someone who's in like AP stats, for example, stats is very much more, it's still math, but it's also much more focused on like analytical and logical skills. And in a lot of English classes, you're assigned to take your reading and analyze it and thinking. So it can definitely be it's definitely possible for
Yeah.
calculation.
Yeah, exactly. And again, just like we talked about last session, it's if we do a kind of task analysis on these topics and study like people's or students' specific mental processes in doing each of these topics, although on the surface they might be very different, but in depth, they are basically very similar, like composing some writing or doing some math or solving a mathematical problem or a statistical problem. They may not be as different as we think they are. So yeah, that's a question that still exists. And there were a lot of controversy at the time that Spearman introduced the idea. And it created a lot of controversies after that because those tests or abstract intelligence tests were widely used with a lot of controversies surrounding it. And so just to give you an example of such an intelligence test as the abstract test or abstract task that they use is Raven's progressive matrices. And it is something like this, for example, that if like there is this series from top left from here, and then we go down, and then you see which one of these should come here. Which figure logically, as they say, belongs on the spot of the question. So you might argue that why should we assume that there is a true answer to this question? What is a true answer? Can be any of them. And you can justify your choice in n different ways. But if you think about it, a lot of people would reach to this logical conclusion that, for example, they are following like certain pattern, they're moving, this one from right is moving to the left. This one again from right is moving to the left. This one that comes lower should again be moving from right to the left. So this is basically what I think they say should be the right answer. But again, with a lot of controversies. So this is an example of that kind of questions that you might see on intelligence tests. So the key question is that, do they really work? If we test people on these types of abstract materials, can we really predict their performance in the real world? Again, some researchers found evidence, especially in industrial and organizational psychology or applied psychology. And most of the evidence is again for closed skills, not open skills, not things like general military skills or managerial skills, but more on closed skills that follow certain steps, are often associated with using a system. But again, there's a lot of controversies on its validity of these types of tests and whether they can validly be used to predict people's performance. So you might find a senior engineer or a senior person in some occupation who has spent years getting better at that specific task. You may have that person pass these tests and may not score that well. But nonetheless, that person is the senior person in that company and really knows his or her job well. There are a lot of these cases that you can find in the world. So if you go to the job market, for example, and if you apply to different types of jobs, you may find some companies ask you to go through that kind of test. Even I myself didn't believe that it still exists, but they do. Examples like that, Raven's progressive matrices or mental rotations, those tests still exist and companies still use them. Yes.
I was just gonna say, my friend recently just said whenever he was applying for an internship, he didn't make the packaging test.
Yes, exactly. So they still exist. And some companies still believe in them, although they have to have a good legal team behind it to justify its usage, because it may cause certain types of discrimination that may be problematic for those organizations. But again, it exists in some companies even for internship, and some companies use them. So it's a belief. A lot of companies don't believe in them. Some companies do. And again, guess who was the primary figure who opposed the idea of using these general intelligence tests at the time? The same person, Edward Thorndike. And he basically believed in what we said. He said that people might be good at certain specific things, but not in other topics. And we should not constrain ourselves or try to make ourselves believe that people's intelligence is general. They are either good at certain things or not good at anything. So it's basically this belief that Thorndike had, that people are very subject specific. I may be good at certain things, but very bad on other things. Do you have any question? Yes.
So like the studies that they did to see that there's correlation between general education and applied specific skills. I feel like potential problem with that is if they find somebody who, let's say, is good at writing, for instance, and they want to see if there's a correlation between the good writing skills and the good math skills. Wouldn't like a possibility be they're good at math because not because they have strong writing skills, but just because they have stronger exposure to education, and have more experience being a student.
Yeah. Actually, as far as I know, skill like verbal skills and skills in writing is the one that has the highest level of, as they found, correlation with future performance or future job performance or task performance of people. And it's not math that has the highest correlation, but writing and verbal skills. And it was interesting because usually people think otherwise. But yeah, that's why a lot of companies that do like job interviews, one of the first and foremost thing that they care about is your verbal skills or verbal dexterity, both in talking or answering those questions. And they might even ask you to write a piece or write something, especially for academic jobs or professor jobs. They ask you to write a piece, or they see your teaching statement, research statement to see how good you are in writing some pages of text. So yeah, they put a lot of emphasis on writing skills. That's what I know. But you can just search internet to see what are other things that they use or what are the correlation that they have with like specific certain topics with future performance. Any other question? So, as you know, there are also belief in using, in like practicing tests such as solving Sudoku puzzles or practicing with Rubik's Cube, because it is believed that they can train your brain. Because again, they follow certain logical steps. And if you practice on those certain logical steps, you can get better in those types of skills that might be applied to a lot of other tests. So we actually have a lot of parents who believe in these notions and encourage their children to start solving Sudoku puzzles or solving Rubik's Cube with a belief that it's beneficial for the development of their children. So as you can see, this belief in far transfer has impact on almost every aspect of our life, from the structure of our educational system, testing, and in job interviews, and a lot of other places. So just as we saw, in high school, we should practice tests that is considered as beneficial. In finding jobs, we might see things like tests of general intelligence. And these are all representations of, different representations of the belief in far transfer. So these are all abstract tasks. And they do not have immediate real world representations or use, but they are believed to mean something or indicate something or predict something. So with all of these considerations of having real world examples of how far transfer can be seen in educational system in other places, we can just go back to our topic of training and designing training simulators. And asking this question from you now in the shadow of whatever we covered today, that why do you think, I mean, this was a question that we asked last time, there were some reasons, but now under this, whatever we covered today, why do you think training scientists design low fidelity materials in training? So just to remind you, we covered things like lowering the costs, increasing the efficiency of training, and increasing the generalizability of the skills. We talked about them last time, but what are other reasons?
Let's focus on specific tasks and more information on general knowledge and intelligence.
So yeah, that it is basically like low fidelity trying to teach generalized tasks or general tasks that can be applied to a lot of specific examples, and that's why we talked about its increased efficiency in training. Any other reasons?
Can we talk a little bit about how social systems can help somebody return to a task, develop
So did we talk about, can you please?
So like, when I make this like a little bit more basic, that someone more beginning, than like, rather than
Okay. Not yet in detail. We haven't talked about it, but that's one of the reasons that can be considered as one of the main uses of low fidelity systems, to start people who do not have any skill in the task, to starting them with low fidelity simulators to just give them some basic familiarity with the task. That's one of the reasons. Yeah. Yes.
let's say, it'd be like, let's say you teach someone, like, and then they can use that, later on, like, they'll just learn like this, but they can use that when they do. Or they can like, get on the class, going to things that generalized.
Yes, that was the idea that we talked about in like educational system. But here our focus is on the reason that training scientists design low fidelity materials in training simulators. Your point is exactly right in that whole idea of general education, that yeah, math can be used in a lot of things like physics and statistics. And that's why math is useful and should be taught in school. And now the question is why training scientists design low fidelity materials. Yes. So you think that it is because low fidelity gives like a backbone. Yeah, that they can later be developed into a higher fidelity system. So if you think about like what we talked today, again, in addition to reducing time and cost, we can think about things like training the brain in general purpose tasks that one might argue that we have, imagine the task of troubleshooting, that we have an abstract low fidelity simulator or material to train troubleshooting. And that training scientist might argue that it does not just train the troubleshooting itself, but for like recruits in the Army or Navy, it is also a kind of a general purpose training or brain training in general. So it's beneficial per se. Just as the reasons that we covered today for the reasons of general education and other things. And another reason might be, or another justification for using those low fidelity materials in training can be that early on, we can recognize or detect those individuals that show more aptitude or show more skills early on that task, and to select them who are seemingly better from those that are not, and then sending them to more advanced training, for example. It is just like those tests, standardized tests, or even tests of general intelligence, that some people score higher, so they are more likely to be better in that type of tasks. So we just detect them, we distinguish them from others. So these are other justifications for using low fidelity simulators. Of course, just as we talked about last time, the main motivation of developing low fidelity simulators came from saving costs, reducing costs. But as we saw today, after decades, based on this whole idea of general education, intelligence tests, and others, there are also other reasons or other uses of using low fidelity materials.